Hello everyone, so in this video we will be discussing the derivative, slope, and rate of change still under the differential calculus discussion. So now, can we determine the derivative of a function? So there are a few steps in determining or obtaining the derivative of any function. First is, we need to replace x by x plus delta x. The triangle here is read as delta, or y by y plus delta y. So that being said, given a function here, y is equivalent to any function, you need to replace y by y plus delta y, and as well as the function or the variable in the function. Let's say we have the x, so we need to replace x by x plus delta x. So now from this equation, first equation, we already have the second equation. So by subtraction, we need to eliminate, or elimination between 1 and 2, between the first equation and the second equation, thus obtaining a formula for delta y in terms of x and delta x. So that being said, in order for us to isolate the value of delta y, we need to move the y to the other side of our equation. So that gives us f of x plus delta x minus y. And then afterwards, we need to substitute the value of the y. In this case, the value of our y is f of x. Now we need to substitute that here in our y. And then by some suitable transformation, there can be cancellation or something, combination of common terms. Then throw the right member of equation 3 into form, which contains delta x explicitly as a factor. Now afterwards, after we have one variable here in the right side of our equation, then we can divide the function or all the equations by delta x. So dividing delta y by delta x, so that gives us f of x plus delta x minus f of x divided by delta x. And then we can determine the limit as delta x approaches to 0. So that being said, we need to replace or substitute all the values of delta x by 0. So pretty much that is the determination, or that is how can we get or obtain the derivative of a function. So now let's just try to solve some examples. So we have here an example: find delta y over delta x. So our function is y is equivalent to 2x squared plus 3x plus 5. So in order for us to find the derivative of this one, is we need to follow the steps that was stated from the previous slide. So again, we need to replace or substitute the value by y by y plus delta y. So we have y plus delta y. And then also the x, we need to replace that by x plus delta x. And then we have the squared. And again, all the values of x, we need to replace that by delta x. And then we have the 5. Now afterwards, we need to isolate delta y. So we need to move y to the other side of the equation. So we have delta y is equivalent to 2. And then since this is a squared of a binomial, so we just have to perform the operation. We have x squared plus 2x delta x plus delta x squared. And then we also have plus 3x plus delta x. We'll just perform that later. Plus 5 minus y. So again, our y is equivalent to 2x squared plus 3x plus 5. So meaning to say, we have 2x squared plus 2 times 2x delta x, we have 4x delta x plus 2 delta x squared. We also have plus 3x plus 3 delta x. And then we have the plus 5. Now we need to substitute the value of our y by the given value of our y, which is 2x squared plus 3x plus 5. So we have 2x squared plus 3x plus 5. Now, it is important that you enclose this function by parenthesis because, again, this is minus. Now, you also need to substitute or you also need to distribute the minus sign into the function. So, if you will not put a parenthesis here, you might mistakenly um, understand that as minus 2x squared plus 3x plus 5, in which, in that case, it will be incorrect now. So now let's just perform this operation and simplify as much as we can. So we have 2x squared plus 4x delta x plus 2 delta x squared plus 3x plus 3 delta x plus 5. We have plus 5 minus 2x squared minus 3x minus 5. Now again, since we can cancel some terms here, as you can see, minus 2x squared and 2x squared, that is just 0. 3x, we have 3x here, minus 3x. We also have 5 minus 5, that is just basically 0. So what we have left is 4x delta x plus 2 delta x squared, and we also have the 3 delta x. So this is what we have left now. We have delta y. Now after this one, after all the transformations that we did, we have to divide both sides by delta x. So that being said, we have delta x here, and we also need to divide that by delta x. So delta y now divided by delta x is, so 4x delta x divided by delta x, that is just 4x, since that will be cancelled. 2 delta x squared, we can cancel one of this. So what we have left is 2 delta x. And then 3 delta x divided by delta x, that is delta 3. So we now have 3. So this is now what we have left in the function. Now what's next is, after we divide that by delta x, is we need to identify as the limit of delta x approaches to 0. So delta y over delta x, limit of delta x approaches to 0 of 4x plus 2 delta x plus 3. So meaning to say, we need to replace the value of our delta x by 0. So we have 4x plus 2 times 0 plus 3. So 2 times 0, that is just 0. So so the final answer that we have now is 4x plus 3. So this is now our delta y over delta x. So this is now our final answer. So as you can see, this is just a basic determination of the derivative of the function. Now let's move on to another example. So we have here, find the delta y over delta x of y is equal to 1 over x squared. So from here, the same process, we need to again follow the same process all over again. So we have y plus delta y is equivalent to 1 over x plus delta x squared. So this is the first step, or the step in A. Now we need to isolate our delta y by moving our y to the other side of the equation. So we have x plus delta x squared minus y, and then substitute the value of y by its value. So we have x plus delta x squared minus 1 over x squared, right? So this is the value of our y. So now we need to transform or perform some operations that we can here to simplify the function. So we have x squared plus 2x delta x minus 1 over x x squared. So after that, since we cannot we cannot cancel some terms here anymore, then we can just combine these fractions here. So let's try to combine that by determining the GCF. So we have, or the LCD. So we have the LCD now is x squared times x squared plus 2x delta x plus delta x squared. I'm sorry, that is plus delta x squared. So rewriting this one, we have plus delta x squared. So this is our LCD, right? And you already know this from your previous math subject on how to determine the LCD. Now, in order for us to get this value, 1 over x squared plus 2x delta x plus delta x squared, is we need to identify the numerator. So in this case, our numerator is x squared. And then for this one, our numerator is x squared plus 2x delta x plus delta x squared. So simplifying this one, we have x squared minus x squared minus 2x delta x minus delta x squared all over x squared plus 2x delta x plus delta x squared. So since we can cancel this one and cancel this one, so what we have left is negative 2x delta x minus delta x squared all over x squared times x squared plus 2x delta x. This is the denominator. Now, after that, we need to, since we cannot cancel terms anymore, then we need to divide both sides by delta y, right? So, dividing this by delta x. Then this one as well, we need to divide that by delta x. And again, in dividing fraction, we just have to multiply that with the reciprocal of our denominator, tama? So we have 2x delta x minus delta x squared multiply that by the reciprocal of our denominator, which is 1 over delta x. So meaning to say this will be cancelled and one of these will be cancelled. So what we have left is negative 2x minus delta x all over the denominator. Copying the denominator, we have 2x delta x plus delta x squared. So after that, we need to take the limits as y approaches to x. So we have limit as that's delta x approaches to 0. Afterwards, substituting all the values of delta x by 0. So this will become 0. This one also becomes 0, and this one will be 0 because we have substituted that to 0. So what we have left now is negative 2x over x to the fourth, because x squared times x squared, that is x to the fourth. Now we can still simplify this because x can still be cancelled. So what we have now is negative 2 over x cubed. So this is now our final answer. So we have another example. We have y is equivalent to square root of x plus 2. So the same process again. We need to replace the variables by y plus delta y and x plus delta x. So we have y plus delta y is equivalent to square root of x plus delta x plus 2. So isolating the delta y, we have square root of x plus delta x plus 2 subtracted by our y. So in this case, our y is square root of x plus 2. So afterwards, since we cannot do anything about this anymore, and what we need to do is we need to at least cancel the radicals. So what we need to do is we can multiply that by the conjugate of this function. So the conjugate of this one is x plus delta x plus 2 plus square root of x plus 2. And then divide that by the same function. We have x plus delta x plus 2 plus square root of x plus 2. So again, since this involves radicals, then you can just perform multiplication of its conjugate. Now, this is understood to have a denominator of 1, right? So multiplying the fractions that we have square root of x plus delta x plus 2 multiplied by this one is just equivalent to 1 half plus 1 half, that is just equivalent to 1. So we have x plus delta x plus 2, and we also have to multiply this to this one. So we have plus square root of x plus delta x plus 2 times square root of x plus 2. And then so we also have this one. So that gives us minus square root of x plus 2 times square root of x plus delta x plus 2. And then square root of x plus 2 times x plus 2. So that is just equivalent to x plus 2, right? And then we have to divide that by our denominator, which is square root of x plus delta x plus 2 plus square root of x plus 2. So we just have to copy this one. Now, we can cancel this, and we can also cancel this, since square root of x plus delta x plus 2 times x plus 2 minus, it's the same term in exactly the same terms, that is just equivalent to 0. So that gives us x plus delta x plus 2 minus x and minus 2, because this is minus, right? So minus x and minus 2. So copying the denominator, we have square root of x plus delta x plus 2 plus the square root of x plus 2. So what we have left now is delta x over square root of x plus delta x plus 2. This, erase this one, plus 2 plus square root of x plus 2. So afterwards, after we have transformed or simplified the function, we can now divide both sides by delta x. So dividing both sides by delta x, dividing a fraction again, that is just 1 over delta x, right? Multiplying that by 1 over delta x. So let's just remove this one in order for us to have no miscommunication or misunderstanding. So delta x and delta x, that's cancelled. So what we have is square root of x plus delta x plus 2 plus our square root of x plus 2. And then afterwards, we need to identify as the limit of delta x approaches to 0. So we have delta x approaches to 0. So what we have now is cancel. This will be zeroed out. So what we have is x plus 2 and x plus 2. Now, radical with the same values or terms inside if you add that together, that is just equivalent to 1 over 2 square root of x plus 2. So, this is now our final answer. So, I hope this part is clear with all of you, and if you have any questions, you just have to feel free to message me in our LMS. So we have here the another topic, which is the derivative interpreted as a slope. So basically, it is just the same process. It's just that it is interpreted as a slope. So if you can remember, we have here the equation of the line, which is y is equal to mx plus p, and m here is what we call the slope, and also m is equivalent to the change of y over the change of x. Again, delta is also understand as the changes. That is the change of y over the change in x. So meaning to say the change in y is dependent also with the change in x. So we have here an example for this one. We have to find the slope of the line at points 1 and 3 that will pass through the curve y is equivalent to 3x squared plus x. So in this case, we need to take the function that we have, and that is equivalent to y is equal to 3x squared plus x. So our function is this one, and then you just have to take note of the points later on. So we have y plus delta y is equivalent to 3x. We have 3x plus delta x squared. We also have x plus delta x. And then, isolating the delta y, we have 3x squared plus 2x delta x plus delta x squared plus our x plus delta x minus our y, which is this one. So 3x squared plus x. So now, transforming or simplifying the equation, we have 3x squared. 3 times 2x delta x, that is 6x delta x, plus 3 delta x squared, plus x plus delta x, minus 3x squared minus x. So we can cancel some terms, cancel this, we can also cancel this and this. So what we have now left is 6x delta x plus 3 delta x squared plus delta x. So afterwards, after we simplify our equation, then we can divide that by delta x. So dividing our function by delta x, we have 6x delta x divided by delta x, that is just 6x, plus 3 delta x, and then this one and this one, that is just equivalent to 1. Delta x divided by delta x, that is just 1. So afterwards, we can now take the limit as delta x approaches to 0. So we have delta y over delta x, again as limit of delta x approaches to 0. So we have 6x plus 3 times 0 plus 1. Now this is 0, so we have 6x plus 1. Now this is not yet the final answer since we have the value for the points that we have. So in Cartesian plane, this is x, right? And this is y. So x is 1 and y is equal to 3. So from here, in our variable, we only have variable x. So we just have to substitute that later on. So if you can remember, these are the points that we have. And delta y over delta x, that is also equivalent to slope, right? So our slope is 6x plus 1. Now at this point, we have 1 and 3. We need to substitute that to our equation in order for us to find the slope. So m is equivalent to 6 times our x, which is 1, plus 1. So meaning to say our slope is equivalent to 7. So this is now our final answer. So basically the same process as the derivation or in finding the derivative of the function. However, we just have a given points here for the slope, and then you need to substitute that to our slope in order for us to get the value or the final result. So that's it for the derivative interpreted as a slope. Now let's move on to the discussion of the rate of change. So we are now on the last topic of this video. So we will be discussing the rate of change. So the rate of change of y corresponding to the given value of x or the instantaneous rate. So basically, rate of change is interdependent with the variables that we have. So meaning to say as x increases, y also increases. Practically, that is the rate of change. So it is dependent with the variable that we have in determining the rate of change. Now we have an example. Find how fast A, the volume, B, the surface area of a sphere, increases as the radius increases. So meaning to say, we need to find the changes as well in the volume as the radius increases as well as in the surface area. Meaning to say, as radius increases, the volume might also increase and as well as the surface area. So if you can remember, or if you can try to find the formula for the volume of our sphere and the surface area of the sphere. Now, first, let's just try to solve the letter A, or the volume of our sphere. If you can remember, the volume of our sphere is given to have the equation V is equivalent to 4/3 pi r cubed. So this is the formula of the volume of the sphere. Now, since we are looking for the increase in the volume as radius increases, or we need to find the value of the volume as radius increases, meaning to say, same process, we need to take the same process. We have to replace the values of V and R by V plus delta V and R plus delta R. So we have V plus delta V is equivalent to 4/3 of pi R plus delta R, and that is cube. So again, this is just letter A. Now, taking or isolating the value of delta V, so we have delta V is equivalent to 4/3 pi times R plus delta R cubed minus our V. So our V is 4/3 pi R cubed, so I will just replace that directly. So we have 4/3 pi R cubed. Now, we need to simplify first this function. So we have 4/3 pi r cubed plus 3r squared pi delta r plus 3r delta r squared plus delta r cubed minus our 4/3 pi r cubed. Then afterwards, we can distribute 4/3 pi by the terms inside the parenthesis. So we have 4/3 pi r cubed plus 4/3 times 3, that is just 4 pi r squared delta r, plus this one. So 4/3 times 3, that is also 4 pi r delta r squared, plus 4/3 pi delta r cubed minus 4/3 pi r cubed. Now we can cancel this term and cancel this term. So what we have left is 4 pi r squared delta r plus 4 pi r delta r squared and 4/3 pi delta r cubed. So next is, after we have simplified or transformed our function, we just have to multiply or divide that by the delta r. Divide both sides by delta r. So we have delta v, or change in volume, divide by change of our r, or the radius. So we have 4 pi r squared delta r divided by delta r. So that's, the delta r will be cancelled. So we have 4 pi r squared plus 4 pi r delta r squared divided by delta r. So we have 4 pi r delta r. And then we also have 4/3 pi delta r squared divided by delta r. So this will be 4/3 pi delta r squared. Now taking the limits as delta r approaches to 0, so we have, again, delta r approaches to 0. So we have 4 pi r squared plus 4 pi r, and this will be 0 plus 4/3 pi 0. So basically this will be cancelled. This will be just equivalent to 0. So the final answer now is equivalent to 4 pi r squared. So meaning to say, our volume with respect to the change in radius is equivalent to 4 pi r squared. So that will be the answer in our A. Next is, we need to identify the surface area. So we have here the surface area of our sphere. Now the formula for the surface area of our sphere is just equivalent to S, or the surface area is equivalent to 4 pi r squared. So that being said, we still need to find the surface area as the radius increases. So we have S plus delta S is equivalent to 4 pi r plus delta r squared. So isolating delta S, moving the S to the other side of the function. So we have 4 pi r plus delta r squared minus our S, which is this one, 4 pi r squared. Simplifying the equations, or the equation, we have r squared plus r plus 2r delta r plus delta r squared minus 4 pi r squared. Again, distributing 4 pi to the terms inside the parentheses. So we have 4 pi r squared plus 8r. That should be 8 pi r. We have 8 pi r delta r plus 4 pi r squared. 4 pi delta r squared. I'm sorry. Minus our 4 pi r squared. Now, canceling this one since it has the same term. So we have 8 pi r delta r plus 4 pi delta r squared. Now, dividing that by our change in radius, or the delta r. So we have 8 pi r and 4 pi delta r, because this will be cancelled, this one as well. So taking the limits as delta r approaches to 0, so this will be substituted by 0, so this will be cancelled. So now what we have is 8 pi r. So this is now our final answer. So this is the value for the surface area of the sphere as radius increases. So this is now our final answer. And I think that's it for this video. I hope you learned something from this video, and I'll see you on the next videos. Please don't forget to like this video.